This is chapter 6, periodic properties, homework question number 5. Consider the isoelectronic series xenon, cesium ion, barium ion, lanthanum ion. Arrange these species as follows. Okay, so the first one, A, arrange these species in order of increasing atomic or ionic radius. So basically atomic size or ion size, all right? So increasing order. The larger one on the right-hand side, the smallest one on the left-hand side. So in order to help you guys, I made this chart. This is really useful. So basically that's the trend in periodic table. So anyway, let's concentrate on question number 5. So we are talking about the size of atoms as well as the ions. All right. So therefore, once you get a periodic table, you know the size increases from left to right and also increases from top to down to bottom. Okay. So let's identify the 4. Okay, yeah, we should be able to see it. Let me. Okay, so you see we should have cesium, that's atomic number 55, and then barium, atomic number 56, and then lanthanum, atomic number 57. Okay, so the order you can see that's increasing order this way from right to left. So therefore, from this trend, okay, since all 3 are in the same period, cesium should be the largest one, and the lanthanum should be the smallest one. All right, okay, and the barium should be somewhere in between. So therefore, we can place lanthanum, so 3 plus on the far left-hand side. So that's the smallest ion, let's say, or the smallest species among the 4. Okay, in order of increasing, so that's the smallest one, then the second smallest one, or the one that is larger than the smallest one, that should be barium 2 plus, and then cesium plus. So the question is, where should the xenon be? All right, let's take a look. Now let's calculate the ZEF. Okay, so the for xenon first, ZEFF, so Z effective can be calculated using Z minus S. Z is the atomic number. For xenon, atomic number is 54, and then S is the number of core electrons. Since xenon's electron configuration is fully filled, all of the orbitals, so therefore all 54 they are actually core electrons. So therefore that should be 0. And then cesium, it's atomic number, or so the number of protons is 55. So you get that from periodic table. And then the number of core electrons, still 54, should be the same as the xenons. So therefore, it's 1. Then you can work on barium 2 plus and lanthanum 3 plus. Yeah, you can see from xenon all the way down to lanthanum 3 plus, the Z effective increases. Okay, and that would result, you see, the radius of, or the radii of the atom, then is an atom or ions. So the radii is decreased with increasing ZeF. In other words, the size should be increased this way. The smaller the Z effective, the larger the size. So therefore, xenon should be the largest one. That's for A. Okay, in question B, we need to place them in order of increasing ionization energy. Ionization energy, the trend is exactly the opposite of the radii of atoms or ions, okay? So let's say ionization energy. You see, it increases from left to right, from bottom to top, okay? It's exactly the opposite comparing with the radii of atoms or ions. So therefore, the trend should be opposite. The opposite trend found in question 5A. This is CIS, BA.